This is the first part of lesson 8.8, and in this lesson we are going to learn how to simplify trigonometric expressions and prove identities. To begin, let's review some reciprocal identities. These two that I've got listed here, cosecant of theta is equal to 1 over sine theta, and secant theta is equal to 1 over cosine theta, are two that you are not as familiar with. Of course, the follow-up of that is that that sine theta is equal to 1 over cosecant theta, and that cosine theta is equal to 1 over secant theta. Those two are not really that important, because if you know those two, then you'll have what you need as far as reciprocal identities. The next identities we want to review are quotient identities, and that's tangent is equal to sine over cosine, and cotangent is equal to cosine over sine. And so those are two that you need to be familiar with, especially the tangent one. We see that a lot, but if you know one of them, you should hopefully know the other one. This next one is called a Pythagorean identity, and this, I think, is probably the most important one to know besides the basic definitions of your trig ratios. This Pythagorean identity is going to come up a lot. There are a couple of other Pythagorean identities, but I don't feel like they're as important to know. This one is just super basic. If you remember from the unit circle, when we did a point on the circle and we found what the ordered pair was, remember the x and the y, and that's cosine and sine. And so when we did that point and you think about the triangle that's formed, this is your cosine and this is your sine. And using the Pythagorean theorem in a unit circle, it would say that cosine squared x plus sine squared x is equal to 1. And so that's where that Pythagorean identity comes from. So we're going to keep coming back to this Pythagorean identity. It's going to keep coming up, and so you need to be on the lookout for it. A follow-through from this is that if we solved it for cosine squared, meaning if we got cosine by itself, it would be cosine squared theta is equal to 1 minus sine squared theta. And then also if we solved for sine, it would be sine squared theta equals 1 minus cosine squared theta. So those are kind of two little follow-throughs from that, but you want to be watching for that one. It's going to come up a lot. Okay, we're going to start by simplifying some trig expressions. And so just like with any other expressions, we can look for things that will give us clues. And if you remember in your last module, module number 5, where you did simplifying rational expressions, you did a lot with factoring. Like if you had x squared minus 1 over x plus 1 times x plus 3, you would simplify that by saying that the top one was x plus 1 times x minus 1 over x plus 1 times x plus 3, and then you would look for common factors, and then you could factor that, and then you left with something more simplified. And that's kind of the idea of what we're doing. In fact, that module is going to be super helpful in doing all of these simplifications and proofs that we're going to do today. So when we simplify an expression, you need to think about these other things that you know. So if I look at this, I've got a fraction, subtract another number. Now we already know from previous experience and previous knowledge that when you're subtracting with fractions, you have to have a common denominator. And so we need to make this into a common denominator. So I'm going to start by just rewriting the 1 over sine squared theta, so I'm not doing anything different. But instead of writing minus 1, I'm going to make that into a fraction. And I need it to be equal to 1, so I can't change any values, but I need it to have a common denominator. So if I was to multiply this 1 by sine theta over sine theta, sine squared over sine squared, then I am going to be still subtracting 1, but it will be with a common denominator so that I can combine those two terms. So on the numerator, I will have 1 minus sine squared theta over sine squared theta. That's the way fractions work. You don't do anything with the denominators as far as adding them or subtracting them. As long as they have a common denominator, they just are the denominator. Now at this point, you look at that and you remember that we've already talked about if you have something like 5 plus 3 divided by 3, you cannot cancel 3's because those are terms, and you can only cancel factors. That's the exact same thing that we're seeing right here. We cannot cancel sine squared theta because those are terms, not factors. So we have to look for something else. Now, if you remember back on our previous page with Pythagorean identities, look at what we have right there. Sine squared theta is equal to 1 minus cosine squared theta. So if we come right here, instead of that numerator, I could write cosine squared theta. So instead of this, I'm writing cosine squared theta and then over sine squared theta. And then, remember back to our quotient identities, cosine squared theta over sine squared theta is equal to cotangent squared theta. And that is a simplified version of our original expression. And so my final answer is that that expression that I had originally is the same thing as cotangent squared theta. So it's like when we have a fraction and you have 10 over 12 and you simplify it to be 5 over 6. That's just a simplified version, but equal. These two expressions are equal, but one is simplified and one is not. And so that's what we're doing here. Okay, let's try another one. Number 2, simplify cotangent squared x times 1 plus tangent squared x. Now you'll notice as we go through these that we might have x as our input variable. On the previous one we had theta as our input variable. It doesn't matter, those are just variables, and it could actually be anything we wanted. It could be theta or x or different letters. Ones that we use in geometry and trigonometry a lot are x, theta, alpha, and beta. And we'll use all of those just for variety so you can see them. They're just a variable. Okay, so for this one, you look at this, we've got cotangent and tangent. And so originally you might think, well, I don't know what to do with that. The first thing is look for something you already know. So how about we can distribute? Because that's something we've learned to do. So let's multiply cotangent squared times 1. So that's cotangent squared x. And then we're going to do cotangent squared times tangent squared. So plus cotangent squared x plus tangent squared x. Okay, and then we're adding these together. So it's kind of like if I have x plus xy, I can't add those together because they're not like terms. So I have to look for things that I could do. And so let's think of our quotient identities. So instead of cotangent, I'm going to write cosine squared x over sine squared x. And I will tell you that this is one little strategy that you could do, is always look to write things in terms of sine and cosine, and I feel like that helps a lot because then you can get everything in terms of two basic things, and it really does help move you along the path. Sorry, that should be a multiply right there. And then times tangent squared is going to be sine squared x times cosine squared x. Okay, now what we have here is I've got one term and another term. And so if I'm going to add them, I can't do it yet because I don't have common denominator. So let's look at this one right here. And if I look, I'm multiplying. And so multiplying, just focus on that. If I'm multiplying, I can cancel common factors. And so what I have there is I just have 1 because everything's canceling. So I have cosine squared x over sine squared x plus 1. And then it kind of looks like the previous one we did. I'm going to rewrite that with a common denominator, cosine squared x over sine squared x plus, and then instead of 1, it's going to be sine squared x over sine squared x. Now I can put them all as one fraction, so cosine squared x plus sine squared x over sine squared x. Now here again, you cannot cancel signs because they're not common factors. So you got to really be careful that you're not tempted to do that. So now look at it and think, what do I know about this? What do you know about this right here? If you go back, you know this. And so like I said earlier, that's going to come up a lot. And so instead of cosine squared x plus sine squared x, I'm going to write 1 over and then sine squared x. Now go back and look at these reciprocal identities that we had. Okay, so what do we know about 1 over sine squared? It's going to be cosecant squared. And so you just go back to these things that we already learned. And so this is going to be cosecant squared x. And this is the simplified version of that. So cosecant squared x is what this is equal to. cosecant squared x. So it's a process that you have to go through, and you have to be looking for things like common denominators. Can I cancel factors? Do I distribute something? Can I factor something? There's all these things to be looking for, but one of the strategies is look for your Pythagorean identity right there and put everything in terms of sine and cosine. Okay, let's do another simplification. Okay, this one says tangent theta, cosecant theta, all over secant theta. Put everything in terms of sine and cosine. So if you remember in our module, we had a complex fraction, which means a fraction over a fraction, or a fraction divided by a fraction. And that's what we're going to end up with here. So instead of tangent theta, I'm going to have sine theta over cosine theta times, and then cosecant is 1 over sine theta. Now as my denominator, secant theta is 1 over cosine theta. Now when you have a complex fraction, just like I told you in the module, you need to just focus on one thing at a time. Don't try to take in everything. So let's just focus on our numerator. If I look at that, I am multiplying, so I do not need common denominators, but I can look for factors. And what I have here is I've got sine over sine. I can cancel those. So I have left 1 over cosine theta, and that's my numerator. Now come back to our whole fraction divided by 1 over cosine theta. Notice that I have something divided by itself, and any number divided by itself is 1. And so this expression that we had at the very beginning is equal to 1.